Okay, for this first problem, it's probably easiest to make this determination as to which of these curves is the function, derivative, and second derivative based on the slopes of the, what I mean by this is looking at the, where each of these functions has a horizontal tangent line. For example, the dotted line there, letter C, has a horizontal tangent line at those 3 points, which would mean that if its derivative were here, it would the derivative of letter C would cross the x-axis here. Whoops. So here, and here, which none of the other functions do that. So that's probably going to be the second derivative. But let's work our way sort of through this. So let's look at the dashed line. The dashed line has horizontal tangents here. Let's see, right here and right here. And so this should, its derivative should have crossed the x-axis at those 3 points. And in fact, the dotted line does do that. So the derivative of letter A prime is equal to C in that case. You can also check to see that here the slopes are positive, and so here the function values are positive. Here slopes are negative, function values are negative, and so on. So now let's take a look at the gray solid curve. For that one, we have a horizontal tangent there, a horizontal tangent here, and that's it. In addition to that, these are increasing, then it decreases, then it increases. So the derivative of the gray function, solid gray function, should be positive, and then it should be 0 right here, which notice that this dashed line does that. And then it should be negative. The derivative of the gray function should be negative, and then 0 right there, then positive. So that's the way that is. So B prime is equal to A. And so the final answer is that F must be curve B. F prime must be curve A. And F double prime should be curve C. So let's move on to the next one. So a particle moves using this position. Remember that the velocity is derivative of position, and so velocity is going to be the derivative of position, and that's going to be 3/2 t to the 1/2. Bear in mind that this is t to the 3/2. Let's see, minus 3/2. I think that's it. And then the acceleration is the derivative of velocity. And that's going to be 3/4 t to the negative 1/2. When is the particle moving upward and when is it moving downward? Up is when v is greater than 0. Down is when v is less than 0. So we need to know when v is equal to 0. And v equals 0 here, 3/2, whoops, t to the 1/2, 3/2 equal to 0. That gives me t to the 1/2 equals 1, which is t equals 1. So now we just have to figure out which way is this thing traveling on either side of 1. So when t is less than 1, v is, let's see, we can work this out by plugging in a test point. For example, we could plug in the point 0, and we get that v of 0 is negative 3/2. So v would be less than 0. So that's going to be down. And t is greater than 1. V is greater than 0, which is up. And once again, you can pick a test point for this. Pick t equals 2 or something. Plug it in, and you'll find that you get a positive number. How far has the particle traveled? Well, here you have to bear in mind that this thing is going to be traveling down. So let's see, when t equals 0 to t equals 1, so this will be the downward movement, and then t equals 4 is the end of the upward movement. And so t equals 0, y of 0 is equal to 1. That's easy. When t equals 1, y of 1 is equal to negative 1/2, negative 3/2. So I'm just plugging 1 into this function right here. And then t equals 4. Let's see if I can do this one. Y of 4 is going to be 8. 8 minus 6 plus 2. It's going to be 3, isn't it? Okay, so from here to here, we travel 5/2 units. And from here to here, we travel 9/2 units. And so the total travel is going to be 14/2 or 7. Speeding up and slowing down. So speeding up is when the velocity and the acceleration are the same sign. And slowing down is when it's not the same sign. Okay, so we have velocity and acceleration. We basically know when, so essentially we just want to know what's going on with the velocity or the acceleration. So the because we have the velocity information over here. So here, let's do this. T is less than 1 and t is greater than 1. I think these are the only situations that we're going to need to, I suppose technically we should do that. Let me get rid of this. Okay, so here v is less than 0 and a is greater than 0. V is greater than 0 and a is greater than 0. So this is slowing down. This one is speeding up. Okay, one more for this page. Oh no, there's more than one. Just keeps going, doesn't it? Okay, so tangent line. Easy enough. We need the slope. Is going to be y prime at 0. So y prime, got to use the product rule here. So here's the product rule. So just to remind you, here's how this works. We have f is x squared, g is e to the x, f prime is 2x, g prime is e to the x. And so the product rule, you're going to get f times g prime plus f prime times g. Now the derivative of x cubed is 3x squared. And then the derivative of 1 is 0. So y prime of 0 is, I guess, 0. Well, that's boring. Okay, so we've got our slope, we've got our point. So the point is the point 0, 1. And so now you use, so this is the slope. And then the point y of 0 is 1. So y is equal to mx minus x1 plus y1. That's your point slope form of the line. So this gives me y is equal to 0 times x minus 0 plus 1. So y equals 1. Should have picked a more complicated problem. All right, 2 more, and then we'll take a break. So here we're going to use u substitution. Actually, I think we will for both of these. So u substitution, where u is equal to 1 plus 2y, and du is equal to 2 dy. So the way I like to do this is I like to rewrite this so that this is going to be the integral of 1 plus 2y squared times 2 dy, and then I'll put a 1/2 out here. So I'm gonna drop the limits because it just is complicated when you do use substitution. So I'll put them back in at the very end. And but you'll notice that I've got everything balanced here, so that this that matches there, and then of course the 1/2 balances the 2 that I inserted. So this becomes 1/2 times the integral of u squared du, which we all know is 1/3 u to the 3rd. This is a definite integral, so I'm just going to ignore the fact that the plus c is there. So now I'm going to put the limits back in. So this is 1/6 times 1 plus 2y to the 3rd, evaluated from y is 1 to 2. So let's just plug in the upper limit, and I get 5 cubed minus 1/6 times 3 cubed. So you could probably clean that up. 125 over 6 minus 27/6. You could clean it up some more, but I'm happy just to leave it. Well, I guess I should clean it up. So let's see, 125/6 minus 27/6 is 98/6, which we can divide by 2, so that's 49/3. Okay, onward. Now let's take care of this. Here we're going to separate this into 2 separate integrals. Let's change colors. So this is 5r squared cosine r cubed plus 2, and this one. So hopefully you all know that this is the natural log of r. So let's deal with the one on the left. That one, we're going to have to let u equal r cubed plus 2 du is equal to 3r squared dr. And that gives me, sort of notice that there's a 5r squared up there, so I'm going to have to do this. This will be 3, I'm going to move this to the end. Cosine r cubed plus 2. Let's see, times 3r squared dr. Okay, so the 3, it used to be a 5, and so to balance things, I need to multiply everything by 5/3. 5/3 times 3 is 5. Okay, now I can do this. Let's go ahead and do the substitution. This is 5/3 times the integral of cosine of u du. I guess that natural log of r is just going to go along for the ride. And then, I guess I need to shift some stuff around. Didn't give us much room, did I? There. Okay, so that is equal to 5/3 sine of u plus ln of r. Okay, now that I've got all of my antiderivatives, I'm going to just put in my plus c. And then finally, 5/3 sine of r cubed plus 2 plus ln of r plus c. I don't like that. Let me move it. There. That looks a little better. Okay, so next video we'll do the Calculus 2 stuff. Thanks for watching.